R programming language is widely used in the real world, especially in statistics and data visualization purpose. Hi, my name is Surendra Verma and I am your course instructor for R Programming Bootcamp. So in this course I have covered basics of R programming, control structures in R, functions in R, data structures in R, and then plotting graphs in R, and then followed by a bunch of assignments for solving purpose. Okay. So if you are a beginner to R programming course, then you must enroll in this course. And this will give you the basic and fundamental knowledge on R programming. So I wish you a happy journey of R programming. Thank you.
Yes, sir. In this video, I'll show you how to install R Programming IDE. Just write R Programming download in the Google search. Okay. So then you will come across these links and you have to click on this link, the R project for statistical computing. Okay. So the corresponding website link is www.r-project.org. You just click on this link and you will see here. So in order to download R, please choose your preferred CRAN mirror. Okay. So you have to click on this CRAN and click on respective link based on your location. For example, if you are belonging to Australia, you can choose any of these mirrors. Okay. And it will start downloading and you can install it in your system. Okay. Yes, let us discuss about variables in R programming language. So let me first create a variable in R. Whenever you want to create a variable, okay, you can assign a value directly to the variable with the help of arrow sign. So I'll show you here. For example, I want to define my name. So name. So this is the sign which we use here. So you can start writing your own name. Okay. And just you need to press enter. Okay. Now if I want to display my name, so I just wanted to write the variable name. Okay. And press enter. So that will show you the content that is stored inside the variable. Okay. And in another way also you can do it here, that is you can make use of print statement and inside this print you can write name, so which will again show you the result just like that. Okay. So and apart from this you can also basically perform concatenation operation with the help of these variables. So let us consider a couple of variables, like I'm considering text1. Okay. So R programming. Okay. And I'm taking another text here. Text2 is currently holding okay, is awesome. Okay. Now I want to paste both these variables. Okay, that is I want to basically concatenate these variables. So in another way I can say I'm trying to add a variable with another variable. Okay, so let's do this with the help of paste. So take both these parameters like text1 and also text2 and just press enter here, and you can see after concatenation what is the result. Text1 contains R programming and text2 contains is awesome. Now it is able to show you the result, that is paste of text1 comma text2 is R programming is awesome. Okay. And the other thing is you just perform this concatenation operation when you are trying to work with the values, different values. If you wanted to make use of this, okay, plus is the operator that is used. I'll show you here. So consider a different number, like so this is num1. Okay. and I'm showing its value as 5, and I'm taking another number like num2 and its value is 10. Now I wanted to perform this concatenation operation between these two, so then I can perform like this. So which is basically performing what operation here? Okay, addition operation. Okay, so that 5 and 10 will be added here, isn't it? And one more thing is here, whenever you want to assign a same value to multiple variables, you can go for writing multiple variables and assign a value, the same value, and later you can print any of these variable values. Okay, I'll consider var1. Okay, and also I'm considering var2. Okay, and another one is var3. So all this var1, var2, var3 are currently holding a value. Okay, so let us suppose all these are all holding apple. Okay, now when I want to print, let us suppose var1, I'll get result as apple, and suppose I wanted to display var2, again the result is apple, and I'm displaying for var3, again the result is apple. So you can observe here the same value apple is stored across multiple variables and everything is done in a single line. Yes or no? So this is how you can start making use of variables in R. So next, coming to data types in R programming. So as you know, data types is an important concept in any language. So because the variables can store different types of data, right? Okay. So here also in R, we can store different types of data such as numeric data you can store, integer data you can store, complex data type you can store, characters you can store, and also Boolean values you can store. So whenever you wanted to check the data type of a variable, you can go for a class function. Okay. So I'll show you how this class function is going to work across different data types. Okay. So consider x. Okay. And x is holding 10.5. So now I wanted to find out what is the class of x. So I can write class of x. So this will show you numeric because 10.5 is numeric data. Okay. Now let us suppose I wanted to store integer data. Okay. So I'm trying to store like this. X is equal to 1000, and now I'm writing class of x. So what will be the result? Again it will show you numeric. Okay. So if you wanted to store integer data, you always include L after the integer. Okay. So I'll show you here. If I write L, okay, and then I ask for class of x, that will show you integer data. Okay. That is the difference between integer and numeric. Okay. Agree or not? Here this letter L is indicating this is an integer. Okay, that is the meaning of writing L. Okay, now let us focus on the other data types like complex. Okay, so x, I'm trying to store some complex data here like 9i plus 6. Okay, now I can ask the class of x, so that will show me complex data type. This is clearly complex data type. Okay, so as it already contains an imaginary part, I is representing the imaginary part, right? Okay, and next similarly you see here I'm trying to store now a character or a string. Okay, so let's do it. So this is a string. Okay, now I'm trying to print class of x. So you can see clearly it is basically storing character data type. Yes or no? So character type is also known as string here. And now let us store some boolean value. Okay. So consider x is holding true. Okay. Now if I ask class of x, so that will show you logical. Okay, which is also known as boolean here in R. So this is showing logical. This is how you basically understand different data types and how to store values into the variables which are across different data types. And whenever you wanted to print what is its corresponding data type, you can make use of class function in order to check the data type of the variable. Okay, clear? Yes, you can apply simple mathematical operations on the numbers like addition operation, subtraction operation. So let us consider simple mathematical operations here. Okay, so 10 plus 7. Okay, simple mathematical operation. Similarly, 10 minus 7. So that will give you the result. Yes or no? So also you can apply built-in mathematical functions. For example, if I wanted to find the maximum among a set of numbers, I can apply the max function here. So which is built in here in R. Suppose I am applying max function. Okay, among three numbers like 10, 7, 9. What is the maximum value? 10 is the maximum value. Similarly, if I wanted to find out the minimum or lowest number in the given set of numbers, I can apply like this: 5 comma 9 comma 3. So what is the minimum value? 3 here among 5, 9, 3. And next, coming to functions like square root function, in order to compute the square root of the given number, you can make use of the function that is sqrt function here in R. So you can write sqrt of 16. That will give you the square root of 16, which is 4 as a result. Okay. And whenever you wanted to find out the absolute value, let us suppose minus 5.7. Okay, so that will give you the result as plus 5.7, because absolute function always returns the absolute or positive value of the given number. Okay, and next, coming to ceiling or floor function. Okay, so when I apply ceiling function, let us suppose for the same value of 5.7, so I'll get ceil value of 5.7 is clearly 6. Suppose if I wanted to obtain the floor value of 5.7, okay, that will give you 5. Okay, so 5.7 is basically between 5 and 6, right? Okay, so obviously its corresponding ceil value will be 6 and floor value will be 5. Okay, so this type of mathematical functions you can apply clearly in R. Yes, sir. So let's work on next concept in R programming. So for this purpose, you go to repl.it.com and then start creating your own REPL and select R programming. You can see you can work with any programming language almost here. Okay, and if you want to search for R, okay, you'll get R programming, and you just need to create the REPL for that particular R programming. Okay, so once it is created, then you can start working on it. Okay, so you can see here print hello world. If I want to print something, and I can see the result like this. Yes or no? So this is the online IDE which you can make use of it comfortably while working with R programming. Okay. Yes, sir. In this video, I'll show you how to write a if statement in R programming language. So first of all, I'll consider a couple of variables. Okay, and I'll initialize their corresponding values. For example, so A is one variable. I'll initialize its value with 150, and b is another variable, and I'll initialize its corresponding value with 25. Okay, so now I'll write a if condition in order to check whether the relation between a and b is like a is greater than b or a is not greater than b, like this. Okay, so for writing this type of statements, we can simply write if condition. Okay, now here we have to specify the conditional expression. Okay, suppose a greater than b. Okay, I'm writing a greater than b. So what is its corresponding statement? Here we can display, okay, saying that value of a is greater than value of b. Okay, so that can be written with the help of a print statement. Okay, so a is greater than b. Okay, so let's run this code and see the result. So you can see the result is a is greater than b. Okay, suppose if I want to modify this value to 225, okay, and run this code, you can see there is no result produced because a greater than b, 150 greater than 225 condition will become false, isn't it? So that's why this block of statements will not be executed in this case. Okay, so this is how we can write a quick if statement. Okay, now let's see how we can write if else. Okay, so as you know, in this program, if you see here, a value is 150 and b value is 225. So 150 greater than 225 condition is clearly false. So associated block of statements are not getting executed. When I run, I don't see any result here. So but you can actually print that b value is greater than a. Okay, this can be done by writing an else block. Okay, so how can we write else block here? So it's simple. This is a if block, right? Now we can specify else block. Okay, and inside the else block, I'm going to write a print statement saying that b is greater than a. Okay, now let's run and see the result. So here basically you can observe here in the else block, okay, I've written unexpected else in else. Okay, so let's run here. Yes, now you see and understand the indentation here. So always you write else after finishing this if block immediately. Okay, so then this represents this is the else block corresponding to this particular if block. Okay, so you need to be careful here. Okay, and sometimes the value of a and b can be equal also, right? So let us suppose I'll modify this value to 150, and when I run this code, it is still showing that b is greater than a, which is wrong. So in this case, a and b values both are same, isn't it? So that's why we have to modify our code in such a way that it will display a and b are equal when a value and b value are equal. Okay, so let's see here. I'm going to update this code by writing another condition, that is else if condition here. So else if, you have to specify whether a value is equal to b or not. Suppose if the value of a is equal to b, so in that case we can actually print a and b are equal. A and b are equal. Okay, and similarly We are writing another case here. Suppose if a is greater than b, it will execute a is greater than b. Okay. If suppose a and b values are equal, in that case it is going to print a and b are equal. In the else block, we can write b is greater than a. Okay. So we can print b is greater than a. Okay. So let's run this code and see the result. In this case, since a, b values are same, it is able to display a and b are equal. Okay. So this is the advantage of writing else if. Okay. So clearly in this program, you will observe all the different cases. Whenever I change values here, for example, I made a value as 1500 and you will see the result as a is greater than b. Okay. Suppose if I'm modifying this to only 15 and b value is 150, now you will see b is greater than a. Suppose if I'm making this as 150, both the values are 150 and you will see the result as a and b are equal. Okay, just like this. So next one is while loop in R programming. So whenever we write a loop, we have to consider certain things. Okay. So very first one is we have to initialize the loop variable, right? So initialize loop variable. Okay. So let me do initialization of a loop variable. I'm considering I as a loop variable here and I'm initializing I value to 1. Okay. And the second step is you have to write conditional expression for the while loop. Okay. So writing conditional expression. Okay. Suppose I want to basically iterate while loop from 1 to 10 times. Okay. Or I want to display values of numbers from 1 to 10 basically. Okay. In that case, what will be my conditional expression? Okay. So I can write while. So the conditional expression is I value can be less than or equal to 10. Okay. So it can iterate maximum up to 10. Okay. And in each iteration, what is the action performed? Okay. So that is, you have to specify the block of statements that needs to be executed in each iteration. So I want to just display value of I. That's it. Okay. So in order to display, I'm writing print statement print I to display value of I. Okay. And then in each iteration, okay, that is current iteration is I equal to 1. So to move to the next iteration, we have to update the value, right? So loop value we have to update. Okay. So this is update statement which is part of writing a loop. Okay. So in this update statement, so I'll increment value of I by 1 basically. Okay. So I is equal to I plus 1. Okay. So now let's run this code and see the result. You can see the numbers from 1 to 10 are displayed here. Okay. Suppose if I modify the update statement as I is equal to I plus 2, then from one iteration to another iteration, the value that is incremented will be by 2. Okay. So it will display 1, 3, 5, 7, 9 like this. Okay. Suppose if I modify this to I equal to I plus 3, then I'll see the result as 1, 4, 7, 10 like this. Okay. And in fact, you can also modify the conditional expression. Let us suppose I want to display numbers from 1 to 100, where from one iteration to another iteration, it has to increment value by 3. Okay. So in that case, we can write while I less than or equal to 100. Now, if you run this code, you will see the result 1, 4, 7, 10, 13 and so on up to 100. You are able to display the values, isn't it? Okay. So this is how we can write a basic while loop. Now, for example, consider decrementing the loop. Okay. So instead of incrementing the loop variable. So let us consider an example where we decrement. Let us suppose I am taking value of I as 100. Okay, and I want to display all the numbers from 100 to 1. So this is going to be greater than or equal to 1, and in each iteration I am going to decrement value of I by 1. Okay, so I want numbers like this 100, 99, 98, 97 and so on up to 1. Okay, so now let's run this code and see the result. Okay, you will be able to see all the numbers from 100 up to 1. Okay, in each iteration it is decrementing value of I by 1. Okay, so this is how we can implement programs in while loop. Okay, so next one is making use of break statement inside while loop. So whenever a condition is met, I want to come out of the loop. Okay, whenever an event is triggered, immediately I want to terminate this loop. Okay, or move the control out of this loop. Clear? So which is also known as exiting the loop. Now in this case, this is a program to display the numbers from 100 to 1. Okay, so that is basically in the decreasing order, 100, 99, 98 and so on up to 1. Okay, so if this is a case, now I want to terminate or exit from the loop at some point. Let us suppose if I see a number like 85, okay, I want to terminate the loop. Okay, so in that case, we can actually add a condition and include break statement inside it. Okay, so how this can be done is if I write a condition like this where this I value is meeting 85. Okay, so immediately I will break this particular loop. Okay, by writing a break statement. Clear? Now if you see the result, so instead of displaying the numbers from 100 to 1, this is going to terminate the loop whenever I value becomes 85. Okay, so let's run this and see the result. You can see 100, 99, 98 up to 86 only it is displaying, because the moment I value becomes 85, it is going to break this particular while loop. Okay, so this is how we can implement break statement. So similar to the break statement here, okay, whenever you want to basically skip the current iteration and proceed to the subsequent iterations, okay, so we can make use of next statement, just like continue statement in other programming languages like C, Python. So we are going to use next here. So when I run this code, you can see the result 10, 9, 8, okay, 7, 6, 5, 4, 3, 2, 1. Okay, so here I'll use this print statement instead of here I'll use here. Okay, because I want next to proceed to the next iteration, right? So that's why we have to write like this. So where you will see value of I getting decremented first and then displaying. Okay, so suppose if I bring this statement also, okay, so that is this particular part also here. Okay, so in that case you will see the clear difference. 10, 9 will be displayed. Okay, and next it will move to the next iteration, but value is not getting decremented, right? Okay, so that's why we have to keep this statement here only. Okay, so every time I value will be decremented, and then it will check whether the I value is equal to 8 or not. If it is 8, it will move to the next iteration. Okay, so let's run this and see the result. Okay, initially 9, and then whenever value becomes 8, it will move to the next iteration. That is why you are not able to see value of 8 as part of the output here. Okay, so this is how next works in R programming. Now let us implement for loop in R programming. Okay, so First of all, let us suppose I want to iterate a loop from 1 to 10 and display the numbers. So in such case, so let me show you, this is a program where I'm trying to display numbers from 1 to 10. Okay. So let's write for loop for this, for x in 1 to 10. Okay. So iterating the loop from 1 to 10 and displaying the x value here. Okay. So let's run this code and see the result. You can observe all the numbers from 1 to 10 is iterated and displayed. Okay. So this is how we can iterate a for loop. Okay. Let us suppose I want to display numbers from 10 to 1. So in that case, I can iterate like this and display the result. 10, 9, 8 up to 1 will be displayed. Okay, that is in the reverse order. This is a program to display numbers from 10 to 1. Okay, and also apart from this, we mainly use for loop in order to iterate and display the list of elements. Okay, so let us suppose iterating through lists. Iterating through a list of elements. Okay, now let us consider a sample list. Okay, for example, I'm considering a list as cars. Okay, so I'm taking a list of cars here. Okay, Tesla, BMW, Ferrari, like this. Now I want to iterate through this particular list of elements and display the list of elements. Okay, I can do it with the help of a for loop here. For x in cars. Okay, now let us iterate and display this x here. Print of x. So it will display each and every element that is stored inside the list with the help of for loop. So you can see very first element inside the list is Tesla, so that is displayed. And after that, second element is BMW, that is displayed. And the third element is Ferrari, so that is also displayed here. Okay. So this is how you can start creating a list of elements and iterate through it with the help of a for loop. Okay. Yes, next one is concept of a function. Okay. So what is meant by a function? We can consider function as a block of code. Okay. And this code will be executed whenever a function is called. So you are going to implement a task inside a function, and whenever the task is needed, you are going to call that function in the program. Okay. And while we are working with functions, you can pass data, which we call it as parameters, to the function. Okay. And also a function can return a value or a data back to the calling function. Okay. So first of all, let me create a function here. Okay. And show you. So I'm creating a sample function. Okay. So just for demo purpose, so I call this as a demo function. Okay, demo function. Okay, and in our programming, we are going to create a function with the help of a keyword called function keyword. Okay, so you have to specify the function keyword here. So that is function is the corresponding keyword. Now we can start writing the statements inside this function. Okay, let us suppose I want to just display hello world. Okay, so I'm displaying hello world. So let's run this code and see the result. So now there is no result because you have implemented the function but you haven't called the function. Okay, so it means whenever we are working with functions, writing a function is not sufficient. Okay, so it is necessary to write a function and also to call the same function whenever it is needed. Okay, so let's see here, calling the same function. Okay, name of the function is demo function, so I'll call this function, okay, demo function. Okay, so when I run this code, I'll see the result as hello world. Okay, because in this program it is going to call the demo function, and immediately the block of statements inside this demo function will be executed, and it is displaying hello world as output. Okay, so similarly you can also pass arguments to the function. Okay, so let me basically show you here displaying, okay, or just passing the arguments to the function. Okay, so in this case I'll take a similar function which is a demo function. Okay, and this function is basically displaying first name and last name of the employee or a student. Okay, so you can consider F name and L name. Okay, so in order to merge these values, that is in order to display the first name and last name after merging, okay, so you can actually make use of another command called paste command. Okay, so that is paste of, you can make use of this F name first, and after the F name I'll display the L name. So this is how I have implemented a sample function which contains some parameters like first name, last name. Now the idea is to call this particular function. Okay, so demo function. Okay, so I'll first give first name, okay, and then last name. Okay, now let's run this code and see the result. You can see it has pasted together, right? First name and last name. Okay, so this is how you can make use of parameters inside the function. Okay, so we can also write functions which can return values in R. Okay, so let us implement a small function which will actually compute a square of the given number. Okay, so I'll call this function as find square function. Okay, so this must be a function, and this function is taking a parameter, because whatever value that is taken by this function is going to square that value and return it. Okay, so function of x. Now we will return the square of this. Okay, which is x into x will give you the square of x, right? Now let us call this particular function by passing some value as parameter to this function. So let us call this function find square function by passing 5 as parameter. Okay, so this 5 will be copied into x here, and it is going to return x into x, that is 5 into 5, 25 will be returned, and it is displayed. So let's run this code and see the result. 25 is the result. So let us suppose I am modifying this value. Okay, instead of 5 I am giving 7 as the input, right? So then the result will be 49. Okay, similarly you can also implement other functions like for example, I want to perform cube. Okay, so find cube is the name of the function, and this function is taking x as the parameter, but this is going to return x into x. Okay, so let us call this function, which is find cube function, by passing some other value. Okay, let us suppose I'm passing 10 as the input for find cube. So let's run this code and see the result. So very first function call is find square of 7. So this is performing 7 into 7 and returns 49. And the second function call is find cube function call by passing 10 as parameter. Now it will take 10 into x and performs 10 into 10 into 10, which is nothing but 1000. So that will display 1000, right? So that is the same result you can see here. Okay. Yes, we can also write nested functions in R programming. Okay. So basically you can call a function inside another function, and also you can implement a function within another function. Okay. So let me write a function inside another function. So I'll call the outer function and inner function. Okay. So basically consider outer function. Okay. This is my outer function, and I have to consider this as a function. Let us suppose it is taking parameter x here. Now let me define an inner function. Okay. So inner function, and this is also a function which takes a parameter of y here. Okay, parameter of y. Okay, now here consider x and y values. We are performing addition operation between them and taking the result and returning the value. Okay, so consider z is equal to x plus y. Okay, and then we are going to return z. Okay, return z. This is the inner function, right? And now I want outer function to return the result of the inner function. Okay, so that is why we can write return of inner function. Okay, so that is inner function. So, and this is very clear, right? We have implemented an inner function inside an outer function. Okay, and this inner function is going to return z, which is after performing addition operation between x and y, the result is stored in z and it is returning z. Now this statement is part of the outer function, which will actually return the value that is returned by the inner function. Okay, now we have to call this function first of all. Okay, so let us get the result. Okay, get the result of the outer function. Okay, so consider I am passing outer function corresponding parameter as 12. Okay, and now we are going to call this result, okay, of, okay, 5. So let's run this code and see the result. You will understand here 17 is the result. Why? Because first I am calling the outer function. The parameter is 12 and this parameter 12 will be stored inside x. Okay. And that is actually taking the result into variable result, and we are passing 5 as parameter to the result function. Okay. So it means the inner function corresponding y value will be 5. So 12 plus 5, the result is 17. Now that is returned by the inner function. Okay. So in fact, that inner function result is returned by the outer function also. Okay. So that's why we are able to display the result as 17 here. Okay. So this is how it is going to work here. Okay. So next one is concept of recursion in R programming language. So in any language, recursion means a function calling itself. is called recursion. Okay. Suppose if you want to implement, let us suppose 4 factorial. Okay. So you can solve the same problem using 4 into 3 into 2 into 1, which is an iterative procedure. Whereas in case of recursion, so how you can actually solve this is by writing 4 into 3 factorial, and again this 3 factorial can be computed as 3 into 2 factorial, and 2 factorial can be computed as 2 into 1 factorial, and so on like this. So this is a recursive approach, right? So let us implement a program in recursion, okay, for factorial. So first I'll call the name of the function as fact. Okay, so this is a function which will take x as parameter. Okay, now in this factorial function, okay, so whenever x value is less than or equal to 0, okay, then I'll return 1 immediately. Okay, so we can return 1 here. Suppose if the value of x is greater than 0, okay, so in that case we can return x into factorial of x minus 1. Okay, so return, that is x into fact of x minus 1. Because how do you compute the 3 factorial? Okay, 3 into fact of 3 minus 1, which is 3 into 2 factorial, and then 2 factorial will be computed as 2 into fact of 1, so which is nothing but 2 into 1 factorial. Okay, and again 1 factorial can be computed as 1 into fact of 0, so fact of 0 is going to return 1, right? So this is how the recursive calls are going to end one by one. Okay, so let's call this fact function here. Okay, so fact of, I'm passing value of 5 here. Okay, so let's run this and see the result. You can see the result is 120 because 5 factorial is computed as 120, right? Suppose if I'm computing fact of 4, the result is 24, isn't it? So this is how you can implement a simple recursive program in R. Okay. Yes, sir. Let's start working with vectors. So what is meant by a vector in R programming? So it is just like a list of items that are belonging to similar data type. Okay, so that is of same data type, you are going to store list of items in a vector, and we'll be using a C function in order to store, okay, all the elements of same type in a vector. Okay, so let me take an example for this. I'll take fruits. Now I'll just mention all different fruit names here. Okay, making use of C function, and all the list of elements should be separated by comma. Okay, and use okay, string representation. Let us suppose banana. Okay, and then apple, and then orange. Okay, so these are the different fruits. Okay, now I want to print these fruits, so I can write print of fruits. Okay, so let's run this code and see the result. So you're able to obtain all the fruit names that are represented inside this fruits vector. Okay, so similarly, if you want to basically write vector of numerical values, you can also do it. Okay, so let me consider this time numbers. Okay, I'll take some numbers here. Okay, using C function, I'll write different numbers like 1, 2, 3, 4, 5. Okay, now you can start displaying this vector of numbers here. So once you run this code, you will see the result. 1, 2, 3, 4, 5 is the result. Okay. And whenever you want to create a vector with different numerical values in a sequence, you can also make use of colon operator. Okay. So instead of writing C of 1, 2, 3, 4, 5, which are in a sequence, I can also write like this 1 colon 5. Okay. And then this is going to create a vector containing numbers from 1 to 5. And then I'm going to display numbers. So you can see the same result is obtained. Okay. Suppose I want to modify this as 15. Then you will see 1 to 15 numbers will be displayed because they are basically stored in a vector and then we are displaying it. Okay. And also, for example, if you want to basically represent the numerical values, then also it is possible. So let us consider this is 1.5. Okay. And I want to represent here as 7.5. Okay. Now you still be able to get the vector of decimal numbers. Okay. So you see here representation. So 1.5 to 7.5. So incremented by 1, you can see 1.5, 2.5, 3.5, 4.5, 5.5 and 6.5 and finally 7.5. Okay. And for example, if I want to modify this as 7.3, so in that case what you will get, then you will get numbers which are basically less than this or less than or equal to this. So when it is incremented by 1, you will get a sequence up to 6.5 because 6.5 plus 1 will go to 7.5, which is greater than this number. Yes or no? It means whenever you are working like this, then the vector with this numerical decimals in a sequence where this last element is not used. Okay. So you can consider an example for this. So now let me consider here logical values. Okay, like true false. I'm going to create a vector containing different logical values, that is true false combination. So C of, so let me write this vectors containing elements like true, false, and similarly true, false. Okay, and then you can print these numbers, right? So you can see the same vector I'm able to obtain here as result. Okay, so for example, if I wanted to find the length of the vector, then I can apply the function called length function, which is used to basically count number of elements inside the vector. Okay, so length is the name of the function. So length of, you just need to mention this vector name, length of vectors. Now you will see the result as 4. It represents how many elements are there inside the vector. So there are 4 elements inside the vector. Okay. And then now we will consider implementing a sort function. Okay. So that is first I'll take sample numbers which are in random order. Okay. And then I'll apply the sort function on the vector. So let me consider this numbers vector where I've taken these numbers as let us suppose 9 comma 3 comma 5 comma 1 comma 8 comma 2. So all these numbers are not in sorted order. Now I am going to apply the sort function in order to bring all these numbers into sorted order. Okay. So very simple, print of, you apply the sort function to these numbers. Okay, and run this code, you will see the result. You can see all the numbers are right now in the sorted order, that is 1 2 3 5 8 9. And similarly this is going to apply for even the strings. so which will sort entire vector of strings in the alphabetical order. Okay, so let me take this time some strings. Okay, so I'll basically take completely different strings like which we have already seen. Okay, related to fruits. So I'll take fruits like banana. Okay, this is apple. Next orange, and then mango, and then lemon. Okay, so these are the different fruits. Okay, so now let us sort these fruits. Clear? So apply sort function on this fruits. So let us print by applying sort function on the fruits. Okay, so let's run this code and see the result. You can see here after applying sort function you will get all the elements like this: apple, banana, lemon, mango, orange. Okay, so similarly here, for example, I want to access one particular element from this list of elements. Okay, so in that case I can print like this by directly representing the index. Okay, so fruits of 1, you can see I'll get result as banana. Okay, so index starts from 1 here. Okay, suppose if I write 4, then I'll get result as mango. Okay, and for example, if I wanted to basically print in a sequence like some part or slicing, you can consider. Okay, so I wanted to basically access only the first item and the third item. Okay, so in that case you can write C of 1 comma 3. Okay, so I want only the first item and also the third item. So in that case I can write 1 comma 3. So let's run this code and see. Now you can observe in this particular vector, very first item is banana and the third item is orange. Okay, so that's how we're able to get. And what happens when you try to use a negative index here? Let us suppose I am writing -1. Okay, so what happens when you use -1? This is going to access all the items except for the first item. Okay, when I write -1, it will access all the items except for the first item. Okay, that is why you can see all the items are displayed except the first item as part of the output. Yes or no? So now similarly, whenever I wanted to change one particular value, you can actually change by referring to that particular index and modifying the value. Okay, suppose I want to modify fruits of 1. Okay, with some other name of the fruit. Okay, so let us consider watermelon. Okay, so now I'll print this result. Fruits of, okay, suppose I want entire result. So let's run this code and see the result. So this time the very first fruit is watermelon, and then apple, orange, mango, lemon. Okay, like this. So you can observe we have modified very first index containing data banana is modified to watermelon. Okay, now similarly you can also repeat vectors. Okay, so I'll show you how we can actually repeat the vectors. Okay, suppose I wanted to generate okay, one particular sequence of numbers and you want to repeat the same vector. Okay, So using the rep function, there is a function called rep, okay, which is used for repeating the vector. So let me consider an example here. Repeat, okay, using rep function, I'm going to repeat this vector of 1 2 3, okay, and each of this I wanted to repeat for 3 times, okay. So finally, when you wanted to display this particular vector after performing a repeat operation, you will see the result like this, okay. So each element inside the vector will be repeated 3 times and it will create a vector, okay, and that vector you are displaying here. So you can observe the vector actually contains elements 1 2 3, and now each element is considered and it is repeated for 3 times. So 1 1 1, okay, then 2 2 2, then 3 3 3, like this, okay. So this is how you can start repeating the vectors as well, okay. So let me show you how you can generate different sequence vectors, okay. So we have already seen for numbers, whenever you want to generate a sequence from 1 to 10, you can just need to write 1 colon 10 and then start displaying these numbers, okay, and run this code. You can see the result. So 1 to 10 numbers are displayed, okay. Suppose I wanted to make some bigger steps or smaller steps in the sequence, then I have a function which is a sequence function that will help me to modify the sequence by updating the step value. So I wanted to basically display the sequence starting from 0 and up to 100. I will display by just incrementing the value by 20, okay. Let's run this code and see the result. So the sequence has to start from 0 and increment by 20 and up to 100. You can see 0 to 100 it is able to display. Clear? So this is how you can start working on vectors in R programming. Yes, in this lecture we'll discuss about lists in R language. So in a list you can store different data type items, okay, and this data that is placed inside the list is basically ordered and also changeable, okay. Now look at this list function that is implemented in R, okay. I have taken a similar data items here, but you can also take different data items, okay, of different data types. And now you can see what is the first item inside the list: apple. The second item is orange, and third item is banana. So now I'm trying to print the list 1. So you can see here. So it is completely ordered. Very first element is apple, and the second element is orange, and the third element is banana. Yes or no? So now, how do we access the list? Okay, I want to access one particular element from the list, okay. So in that case, for example, I want to access very first element inside the list. So I'll get result as apple. Apple is the first element inside the list, okay. And we can also change the item from the list by modifying it, okay. I'll access the very first item, which is apple, okay. Now I'm modifying it to lemon, okay. Now when you run this, you will get result as lemon. And also if you want to basically display the entire list, you can display like this. So this is lemon, very first item, because initially the list containing the first item as apple. Now I have modified it to lemon and then printing the entire list of items. So that's why we get lemon, orange and banana, okay. And Whenever you want to find the length of the list, you can make use of length function, which will return the number of items inside the list. Okay, so basically here also I'm just making use of length function. Okay, so I'll print by calling this length function and passing list1 as the parameter. So this will identify the length of the list1. It means how many items are there inside list1, and it will return it, which is basically it will display that particular result. So you can see here 3. It is going to display 3 because there are 3 items inside the list. Okay. And now whenever you wanted to check whether one particular item is existing inside the list or not, that can be done with the help of percentage in percentage operator. Okay, so it is used basically to just find out whether a specified item is available inside the list or not. Okay, so I have already specified my list1 containing 3 elements. Now I am going to just check whether the one particular item is existing inside the list or not. Okay, so for this purpose I'll write the item. For example, apple. I wanted to check whether the apple is available inside the list or not. So this can be done like this. Okay, is this available inside list1 or not? Now when you run this, you will get result as true because apple is the very first element inside the list. So since it is available, you are getting result as true. Suppose if you mention here something like lemon, and the lemon is not available inside the list, so this is going to display you false. Okay, so that is how you can actually check whether the item is existing inside the list or not. Okay, now let us see how we can add one more item into the list. Okay, so you can make use of append function in order to add one more item to the list. Okay, so I'll go for append function. Now I'll make use of this list1 which I have created, and I wanted to add one more item which is lemon. Okay, and after adding this particular item with the help of append function, okay, so I will display the entire list of elements. Now you can see the result. Lemon will be the last item. Okay, so what is happening here? So the list1, okay, append of, basically I'll show you here, append of list1 comma lemon. Okay, so here the element or item lemon is appended, and also we are able to see the result. Okay, so it is going to display the list1 after performing this append operation. Okay, so that's why we are getting result as apple, orange, banana, lemon. Okay, so for example, if you wanted to modify the position of this element where you are performing insertion, the current insertion is done by adding the element at the end of the entire list. But now I want to modify this list by changing the position. So let us suppose I wanted to insert this after 2, after index 2. So now when you run this code, you can see the result. So after 2, in the sense after 2 elements, lemon is added. Okay, now the result will be apple, orange, lemon, banana. Yes or no? So now whenever you wanted to basically remove the list of items, you can still perform this. Okay, with the help of negative indexing concept. Okay, so let us suppose I wanted to create a new list from this. Okay, I'll go for creating a new list, and this new list is obtained from the existing list called list1, where I'll use index as -1. Okay, and then I will print this new list. Okay, so let's run this code and see the result. And you can observe the result is orange banana. Okay, why it is like this? Because when I mean list 1 of minus 1 except the first element, all the remaining elements are taken from the list and it will create a new list. Okay, now I am trying to access this new list content. That is why I got the result as first element as orange and the second element as banana. Okay, so this is how it is going to work. And for example, if you wanted to access a range of indexes, that is, let us suppose I am trying to add some more fruit names here. Okay, so one is lemon, the other one is kiwi. Okay, like this. Now I want to basically print elements of list 1. Okay, 2 to 4. Okay, let's run this code and see the result. So 2 colon 4 represents elements inside list 1 which are stored at the indices 2, 3, 4. So this is index 2 and then this is index 3 and then this is index 4. So all the elements which are at this indices from 2 to 4 will be displayed. Suppose if I modify this as 5, then 2 colon 5 represents elements at indices 2, 3, 4 and 5. Okay. And also whenever you have a list of elements like this, you can start printing these elements with the help of a for loop as well. Okay, you can iterate using for loop. So you can see for x in list 1. Okay, now I'll start printing these elements which are inside this list. So print x, you can see here. Now when you look at this result, this is going to display like this because in each iteration it is going to print each element. Okay, so starting from the very first element inside the list up to the last element, so all the elements are clearly displayed as part of the output. Okay, so now I'll show you how do we join two lists. Okay, consider list 1, and this list 1 is created by taking elements like A, B and then C. Okay, these are different elements inside list 1. Now similarly I'll take list 2, so it contains different elements like 1 comma 2 comma 3. Okay, now I want to merge these two lists or join these two lists. Okay, so which is nothing but concatenation operation I am performing here. Okay, C of okay, I am trying to use a C function which will actually combine these two elements together. So list 1 comma list 2. Okay, and finally this concatenation operation result is placed inside list 3, and now I'll be displaying this list 3 content, and you can see the result A, B, C are there, and after that 1, 2, 3. Okay, it's basically merging or concatenation of these two lists inside list 3, right? And list 3 contains elements A, B, C, 1, 2, 3. Okay, just like this. Yes, in our programming language, we use a plot function in order to plot the graph. Okay, so usually this plot function will have two parameters. The first parameter is representing the point on the x-axis, and the second parameter will be denoting the point on the y-axis. Okay, so let me draw a simple plot here. Okay, so consider plot of, okay, plot is a function, and the first parameter is taking x coordinate, and second parameter is taking y coordinate value. Suppose I am writing a plot of 1 comma 3 here, so you can see this graph clearly. So exactly at 1 on the x-axis and 3 on the y-axis, Okay, there is a point. Yes or no? Suppose if I want to draw 2 points in the diagram, okay, then how I can indicate it? So let's see here. So the idea is to consider 2 points, right? So I'm taking plot, okay, C of 1 comma 8. This is my first point, and similarly I'm writing the second point here, 3 comma 10. Okay, so now you will see this. So this is the very first point which is denoting C of okay, and the second point is here. You can see. Yes or no? So first one is at the position 1 comma 3 and the second one is at the position 8 comma 10. Okay. So here this is at the position 1 comma 3 and this is at the position 8 comma 10. Okay. Now similarly we can also plot multiple points over here. Okay. So consider plot function where I'm considering multiple points like C of 1 comma 2 comma 3 comma 4 comma 5, and another point is C of 3 comma 7 comma 8 comma 9 comma 12. Okay, so here I'm considering multiple points, and you have to consider the same number of points in both the x-axis and y-axis here. Okay, so let's press enter and see here. So this is the graph that is generated. You can see. Okay, so the same thing I can organize in a better way. Okay, I'll show you how we can organize the same thing here. Okay, so is first I'll consider x. Okay, x-axis corresponding points as C of 1 comma 2 comma 3 comma 4 comma 5. Okay, and similarly y corresponding points as C of 3 comma 7 comma 8 comma 9 comma 12. Okay, so now let us call this plot function by passing x comma y as parameters and press enter. And now you can see here I've taken x coordinates clearly 1 comma 1 2 3 4 5 and y coordinates as 3 7 8 9 12, and exactly the respective xy coordinates are considered like 1 3, there is a okay point here, and similarly 2 comma 7, okay, and then 3 comma 8 there is a point, and then 4 comma 9 and then 5 comma 12. Okay, so these are the 5 different points okay in this particular graph. So let us create sequences of points here. Okay, so this can be done with the help of plot function by writing plot of 1 colon 10. Okay, so this will create a sequence of points. So 1 2 3 4 5 6 7 8 9 10. So all the way starting from 1 up to 10, this will create a sequence of points. So for example, I want to connect all these points basically with the help of a line. Okay, so I can modify this. Okay, so we can actually write it as plot of 1 to 10 comma, and the type of connection between these points is I'll use 1 here. Okay, so wait, yeah, so this is okay, now you can see here. So line L is representing a line which is used to connect all the points in the diagram. Okay, so this is how we can connect. Okay, And suppose if I want to basically customize the graph, okay, let us suppose I clearly want to customize the graph by specifying what is x-axis, what is y-axis, and on the overall title of the entire graph. Okay, that is labels in the x-axis, label in the y-axis, and also the main title of the graph. These things, whenever I want to customize, so we have to write like this. So we are going to use this plot function by writing 1 to 10. Okay, so the main graph is my graph. Okay, and you see this is the x-axis, right? So the x-axis, and y-axis I'm assigning its corresponding label as the y-axis. Okay, now you can press enter to basically see this updated graph where the main title of the graph is my graph, and the x-axis, okay, the label for the x-axis is the x-axis, and the label for the y-axis is the y-axis. Okay, suppose I wanted to change these colors of the points. Okay, so you can make use of another parameter, that is color parameter. Okay, so let me basically consider another example here. So I'm plotting the graph, okay, 1 to 10 points, and assigning the color as let us suppose the color I want is red. Okay, and you will see all the points are appearing in red color, right? Okay, so whenever you want to basically increase the size of this point, okay, so that is to change the size of the points, so you can again make use of this property. Okay, so that is I'm plotting the graph from 1 to 10. Okay, now you have to consider that particular size of the point. Okay, so that is Cx is equal to 2. Okay, so by default it will be 1, right? So when I write 0.5 here, it will be 50% smaller, and if I write 2, it means it is 100% larger. Okay, so you will see here 100% this is larger, right? I mean double the size of the point. Okay, so just like this, we can increase the size of the point as well. Okay, yes, let us create a line graph. Okay, so let me plot line graph, so which is taking points from 1 to 10, and type is line type. L you have to write here. Okay, and you will see this line graph which is connecting points from 1 to 10. Okay, suppose if I want to change the color, okay, so currently this is in black color, right? Suppose I want to modify this color to blue. Okay, so this line corresponding color I want to modify it to blue. So what I can do here is plot 1 to 10. Okay, so again the type of plotting is line graph. Okay, but you have to specify the color here. So by default the color will be black. Now I'm modifying its color to blue. Okay, now you will see this graph clearly showing the color is blue. Okay, suppose if I wanted to increase the width of the line, okay, so you can see this is very thin, right? Suppose I wanted to increase the width of this particular line, so what I can do here is again plot the same graph. Okay, but this time I want the width of this particular graph. Okay, is basically increased to 100%. Okay, so by default it is going to be 1 here. LWD parameter value is 1. Okay, so when I write 2 means it is going to double the thickness of the line. So let's run this and see the graph. So you can see the thickness of the graph is doubled. Okay, yes sir. Now let us generate the pie charts here. So I'm taking x as vectors for the pie chart. Consider 10, 20, 30 and 40. These are different vectors of the pie chart. Now pi of x. Okay, so you can observe this is the pie chart. So the very first one is 10, second one is 20, third one is 30 and fourth one is 40, right? These are the vector for the pies that we have considered. Okay, now let us work on creating the bar charts. Okay, so let us consider x as vectors. Okay, like a, next one is b, next one is c, and the next one is d. Okay, and similarly y, consider the points as 2, 4, 6, 8. Okay, so now we are creating a bar plot. Okay, y comma names dot arguments equal to x and color equal to red. Okay, so I'm creating a bar plot with red color. Okay, and you can see here all these bar plots are in red color. So this is how you can actually create bar chart. Suppose if you want to create horizontal bar chart. Okay, now this is clearly vertical, right? So whenever you want to work with horizontal bars, okay, so then you can also create horizontal bars easily. Okay, so first specify the x corresponding vectors. Okay, so similar to the previous one, you can see I'm taking a, b, okay, c, d. Okay, this is x and this is y. Okay, I'm creating 2, 4, 6, 8. Okay, and also the bar plot I'm creating bar plot of y comma. Okay, so names dot argument is equal to x here. Okay, and this time I'm trying to create a horizontal bar chart, so this must be horizontal is equal to true. Okay, so this will create horizontal bar chart just like this. Okay,